Okay, guys, let's look at gas laws. So we have a couple of concepts that we want to go over, and then we want to get into a couple of math problems. Uh, you can kind of see from the bold text, Boyle's law and Charles' law are the two laws you're really going to want to know. So if the temperature is held constant, the pressure of a gas increases as its volume decreases. The reverse is also true. As the pressure of a gas decreases, its volume increases. So this is Boyle's law. When using Boyle's law, it is understood that the quantity and the temperature of the gas remain constant. And then in the late 1700s, Charles researched the relationship between the temperature of a gas and its volume. He discovered that if the pressure of a gas is held constant, as that gas is heated, its volume will increase. The reverse of that is also true. Cooling a gas will cause its volume to decrease. This relationship is known as Charles' law. And this last point here, pretty significant. Pressure and volume are inversely proportional to each other. So as the volume increases, pressure decreases. And we'll see this at play here in a second. Okay, so here's a first one. You can see a question like this. 2,000 milliliters of a gas at 25 atm is compressed to 1,000 milliliters. What is the new pressure? Okay, so I get my pen here. Blue is a great color. Okay, so in this situation, the volume of a gas is halved. So, right, it's half because we had 2,000 milliliters and now we only have 1,000. So it's cut in half. 1,000 is half as much as 2,000. Because the volume of a gas is half, so the pressure needs to double. Remember that pressure and volume are inversely proportional to each other, right? And so the 25 atm is the pressure, and so because that needs to double, we'll go with our 25 times 2, right? And we'll end up with 50 atm. Okay, so that's how we do that first one, right? And just remembering the key concept, right? The math there is not very difficult at all. That pressure and volume are inversely proportional to each other. Okay, important concept. Okay, next problem. A gas occupies 11.2 liters at 0.860 atm. What is the pressure if the volume becomes 15 liters? Okay, so for this equation, we need to know calculating the relationship between pressure and volume. We need to know this first. I should have wrote this in first, but we have P1, V1, sorry, I lost my pen there, equals P2, V2. Just give me a second to write this guy out there. P2, V2. Okay, so that's important for us to know. And 1 just represents before and 2 represents after. And so in things like this, you'll always be given 3 of the variables, and you have to solve for the 4th variable. Okay, so if we were writing this out, we would go like, okay, so we got 11.2 liters, right? That's what we start with. And 0.860 atm, right? We're just sort of just following that formula of, right, so there's P1, V1. And then we want it to equal P2, V2, yes? And so we know that we have 15 liters, but we don't have anything for the ATM on the other one, so we'll just call that X, right? And so just being able to set up the formula is really the challenge. And then after this, we just have pretty simple algebra, right? We're just going to multiply 11.2 into 0.860. And when we get that answer, we'll just divide it by 15, so we get X by itself. And once we've done that math, we get X equals 0.642. And that will be ATM. Okay, so that's how you do that one, right? And so really the key part here, though, is knowing this. P1 V1 equals P2 V2, right? And knowing that you're going to get 3 of the 4, and that you just have to solve for the 4th one. Okay, pretty simple. Next one. Okay, so we got 500 milliliters of a gas is collected at 745. What will be the volume at standard pressure, which is 760? Okay, so same exact thing, right? Where you have P1 V1 equals P2 V2, and we just have to plug it in, right? So we have 745 times 500 milliliters. Whoops. There we go. 500 equals 760, right? That's given to us as well. And we were not given the milliliters, right, for V2. So now you just go through the process of same thing, right? Multiplying the stuff out on the left. Once you get that answer, then you divide it both sides by 760. And once we've done all of that, we're left with X is 490.1 milliliters. Okay, and that's all you really have to do. And we got one more for you. Okay, so in this one, it says, what is the new temperature when 2 liters at 294 Kelvin, so when you see K like that, it's Kelvin, is compressed to 1 liter? Okay, and so on this one, we do need to know a slightly different formula because we have the Kelvin here. So we go V1 divided by, that's a T1 if you can't read it, equals V2 divided by T2. Okay, so now it's divided rather than multiply. Okay, so V1 divided by T1 equals V2 divided by T2, with Kelvin being a measure of temperature. Again, 1 represents initial volume or temperature, while 2 represents final volume or temperature. Okay, so once we have all of that, okay, so originally we had 2 liters at 294 K, right? So 2 at 294 equals, and then it's compressed to 1, right? So then we just have 1 and an X. It's really all that would be, right? And, or sorry, that's 1 divided by X, right? So really we would want to be able to cross multiply these, so it's really probably easier if you can look at it like this. Right? That probably looks a little cleaner, right? And from here, we would just cross multiply and get 2x equals 294, and then x equals 147. Boom, right there. Right, so there we go, 147 Kelvin. That would be our final answer. So that's really how you go about doing that. Pretty simple, right? So there's the one formula you got to know is here. And in the couple previous problems, I don't think I wrote the equation there. Right here we have P1 V1 equals P2 V2, right? So we did a couple problems with that, and the very first one was remembering that they are inversely proportional, right? And as long as we know that, then we are good to go. Just remembering that pressure and volume are inversely proportional to each other. Okay, if you can do all of those type of problems, you should be good to go on gas laws.